the observations you made, even the students who came in late. Thank you, students who are in here, for helping your classmates get right on track and get into it. So, we are going to talk about our results today and kind of what we found out. So at the beginning, we decided that all of our 3 triangles that the students drew on the board had what? How many sides? 3 sides. Did you find that? What did you find in relation to that with the triangles that you built? Did they all have 3 sides?
No.
Is that a triangle though?
No. This was the fail one.
That's okay.
I just added a couple things to it.
So let's remind Aiden, since he wasn't in here, what our triangle has to have how many sides? James.
I know. This was the original one.
Oh, okay. So that would work for what we're going to talk about at the end. But so 3 sides. All the triangles that you made successfully, did they have 3 sides? Yes? So would you say that all triangles must have 3 sides?
Yes.
Do you agree with that statement?
Yes.
Okay, so let's add that to our chart.
What?
We have a chart right here. So as you notice, we've been doing our comparing and contrasting and reading. Can we do that in math too?
Yes.
Looks like it. Okay, so you guys came up with that all the triangles that you made had how many sides?
3.
Okay, hold up one of your triangles and point to one of the sides. Point to one of the sides on your triangle. One of your sides. Perfect. Okay, according to our, back up here, we're going to get to talk about them even more. According to our Venn diagram, what is another thing that our triangles had in common today? That we might have been a review word. You might call these corners. Caleb?
They were all polygons.
Oh, they're definitely all polygons. We can put that too. What else? Maybe it was a new word for you today that you heard, but maybe you remember it from 2nd grade. Hey. What connects those sides? There's 3 of them. You're right. That's okay. Phone a friend.
They're called sides.
We got the sides. Look up here. Yeah, no, that's good. We got the sides. We have 3 sides. We pointed to the sides. What's another thing that you noticed? Points. Points. So do you see 3 points on all of your shapes? What are they called? Or they could be called corners. What else did we find out they were called today? Do you remember, Yosef? Caleb?
Vertices.
Vertices. Everybody say vertices again.
Vertices.
So vertices are these corners or points, as you said. Those are vertices. If you're talking about one, it's a vertex. Say vertex.
Vertex.
So that is simply where the 2 sides connect. So on your triangles, look at one of your triangles. How many vertices do you see?
3.
On all of them?
Yeah.
Do you think we could add that to our chart?
Yes. All of them have 3 definitely fail. Actually, my fail is actually a non-fail.
All right. Anything else that our triangles have? We haven't talked about this one yet, and some of you have mentioned it in making. For instance, I think Andrew mentioned it, that it had one of these.
Yeah.
What do you think, Hey? Oh,
I'm
raise your hand.
actually going to point out a similarity. Like, you could do this with all shapes. You could find the perimeter and area.
Ooh, okay. So keep that in mind. I do love that. Some of you, I saw that you were finding the perimeter to your triangles, which is great. Talon, what else do you think that all triangles have in common? I heard you say something.
The question was, do they all have 90-degree angles?
Okay, so pay attention to Talon's question. Do they all have 90-degree angles?
Yeah.
Good question, Eliza. Who knows what a 90-degree angle is? Yosef.
Right angle?
A right angle. So if you look at a piece of paper,
This is the right angle.
does this have a right angle?
No.
This corner is a right angle.
Yes.
So we know in squares, how many right angles does a square have? Do you remember, Sophia? 4. So do you think that all triangles have, all 3 of them are right angles?
Yes.
Do you think a triangle could have 3 right angles?
Yes.
Allie, why are you shaking your head no?
Because I think that a rectangle has a acute angle.
Has what?
The acute angle.
Oh, okay, so you're talking about, okay, so what word are we noticing here? They may not have 3 right angles, but they have 3, what is it, a cube?
A small thing that is very cute.
Angle. The common word that you guys keep saying is angle, right? An angle is the amount of space between those 2 sides. So the inside. So right here, these 2 sides create an angle. So if it's a 90-degree angle, it's straight up. There's no, but acute, somebody mentioned that earlier and then Allie mentioned it. Acute, what do you think acute? Do you think that's smaller than a 90-degree angle or bigger than a 90-degree angle? Put your thumb up if you think smaller. Put your thumb down if you think bigger.
You just told us the answer.
No, I didn't. I asked.
Because you said.
So you're right. The way I think of it, we're not even going over acute and obtuse yet, but since you brought it up, we will. So a 90-degree angle is a perfectly, if you think of a square, the square has 4 90-degree angles. They're straight up and across. And acute, I think of it like, it's so cute, it's little. It's smaller than a 90-degree angle. So I want you to take 2 straws that aren't connected yet. And I want you to make a 90-degree angle. If you don't know what a 90-degree angle or a right angle, think of the corner of a piece of paper. 90 degrees. Think of a corner of a piece of paper. Or think of your cubes. Oh, you even put it together. Okay, so do we have an angle here? What is our angle? The amount of space between this side and this side is our angle. What is this angle called again? Right angle or a 90-degree angle. If I went like this,
It's a cute. It's a cute angle.
it's a cute. So is that smaller or larger? What if I went like this?
It's bigger. It's a
It's larger, and you don't have to know the names yet, but that is called what, Andrew? Obtuse. Obtuse. So acute and obtuse means bigger than 90. So,
It's like a.
okay, listen up. So this is 90 degrees. So if it's smaller, anything under 90 degrees, it's acute, which it could be 20 degrees, it could be
30 degrees.
89 degrees, but anything smaller than 90 is acute. But the point that we're trying to make,
Longer than.
just a second, what is our last property or attribute or characteristic of triangles? They have 3 what? What were we talking about in that discussion? We kind of got, Sophia? 3 sides, 3 vertices, and what's this in between those 2 sides? In between the sides, what do we have? The space in between it. What we were just talking about. This is one kind of it. One kind of it. Allie, help her out. Okay, it's a right angle, but all triangles, they don't have right angles, but they all have 3 angles. I'm sorry, I wasn't asking it in a good way. But every triangle, look at your triangles. Do they all have space in between? So hold up one of your triangles. It doesn't matter which one. You have more. So when you're looking at a triangle, we're looking at the sides. Is there space in between the sides? They're not just like this, are they?
No.
They're not laying on top of each other. There's space in between. So how many angles do our triangles have?
3.
Do they all have 3 angles?
No. Yes.
If you have a closed triangle, yes, they all have 3 angles. So that is our last attribute. So, grab one of your triangles. I want to do something real quick. Point to one of your sides. Point to a side. Point to a vertice. A vertex. Point to one of the vertex. So, you should be pointing, yes, to the point or the corner. Perfect. The angle and vertices are kind of hard. They can get confusing. The vertice, if you think of a vertex, is just the point or the corner of the triangle. The angle is the inside, the amount of space that the 2 sides would take up if they met. Okay? So point to a vertex. Point to a vertex. Point to the angle. I know it's hard because they keep coming. So the angle would just be between. Good. Okay. So 3. Does anybody have a right angle or a 90-degree angle on one of yours? Is this a 90-degree? Does it go? Could you put a piece of paper up next to one of your angles? So that if you want to test it out, okay, we're paying attention. Does that? Test it out by putting a piece of paper up to it. So can I borrow yours, Talia?
Mine's not.
So Talia, does this make a right angle? Look at this line and the 2 red. Do those make it? Are they straight up?
No.
This side of the paper and straight.
This one is done.
No, that does not.
This one does.
If I move it, does it have a right angle?
No.
No. Does anybody have a right angle?
No.
Ooh, unique. Did you test yours out with the paper? Did it work? So try putting a piece of. That's a good example. Let's try it. Let's do the test. I need to do it this way. So does this one have a right angle?
Yes.
Over here, does this one have a right angle?
Yes.
Because it matches up with what?
The paper.
The paper perfectly. Obviously, our triangles aren't perfect because they're made with pipe cleaners. Okay, lastly, what did you notice on question 4 about the triangles that did not work, or the sides that did not work? What did you notice about the sides that did not work? Peyton.
I noticed that the sides that did not work, mostly things that didn't work, they always had the white straw.
Oh, okay. So the longest straw. Okay. Allie?
When I did it, there was the sides there. You would have to overlap them, or they would just have to be longer than the straw that you're connecting it.
So we would need an extra long straw. So, okay, good. Good explanation so far. Mila, what did you notice?
I noticed that if you're gonna make one that doesn't connect, we should probably have a small side.
Okay, so you think that it should have a small, oops. So what do we notice? I want you to look at this one that doesn't, Mila said it does not work. What do you notice if I put the 2 short sides against the long side? What do you notice about it? What do you notice about that? Caleb?
It makes a line. A straight line.
Do the short sides, are they the same length as the long side?
No.
Are they even close?
No.
I can't remember who I was talking to about this. Sophia, what did you notice that with yours?
Yes.
So, what did you notice? I want to hear.
noticed that, so this doesn't make a triangle, but if you were to make the white one smaller and put it this way, it would. And if you line them up, that this is not quite as long as the white one, but if you shorten this one or make this one longer, it would be.
Okay, all right. And Peyton, one more thing to add about that?
I actually got that just to make this whole white thing, you need one of the blue straws, one of the green straws, and about half of the yellow straw.
Oh, okay. So what I'm kind of hearing is that if the two littler straws don't measure up to be the same size as your bigger straw, it was unlikely to work. Did you guys find that?
Yeah.
So Andrew, you have the same problem. Your two yellow straws, do they match? Are they as long as the white straw?
Nope.
Not even close. Okay, so that's kind of something to think about. Georgia.
Made of one.
Yes.
It's kind of like a rectangle.
Okay, but let's so let go of the middle for a second. That's a good point. Do you guys still think this is a triangle?
Yes.
That looks like a glass.
Does it have three sides?
Yes.
Does it have three vertices?
I don't know.
And does it have three angles?
Yes.
They're tiny, but they're there. So this is a good point, Georgia, because sometimes triangles, if we move it, we can move it all the way around. Doesn't matter what, it's still the same shape. It's still congruent. And this is a good point because tomorrow you're going to be looking at different shapes and seeing, are they triangles or are they not? So what do you think? Do you think this is a triangle or is not?
It is.
Does it follow all of our rules?
Yes.
All right, keep that in mind